Hi everyone. Okay, so in this video, we are going to be solving equations by using equality of complex numbers. What do I mean by complex numbers? I'm just going to be solving problems where I have two complex numbers equal to each other. So, say for example here, I have complex number, I have say Z1, that is equal to A plus BI. So I have my complex number Z2, that's equal to C plus DI. If Z1 equals Z2, so A plus BI equals C plus DI, therefore, right, they're the same number. So that means the real parts are going to be equal to each other, and then the imaginary parts are going to be equal to each other. So we're kind of equating terms here. So therefore, A equals C and B is equal to D. So let's apply this understanding now to this question. So solve for x and y. So 4x plus 7yi minus 2 times 2 plus 3xyi equals 8 minus 4i. So let's multiply this all out. So 4x plus 7yi minus 4 minus 6xi equals 8 minus 4i. So let's get my left hand side, right? Let's gather my real parts and gather my imaginary parts. So I have 4x, is that real or imaginary? That's going to be a real part because it has no I on it. So 4x, then this minus 4 has no I on it. So they are my real components. Here I have 7yi minus 6xi is going to be equal to 8 minus 4i. So I'm going to have 4x minus 4 plus, factor out an I here, 7y minus 6xi is equal to 8 minus 4i. Now I have my left hand side equal to my right hand side. So therefore, real, imaginary. So 4x minus 4 is going to be equal to 8. 7x minus 6x equals minus 7y minus 6x is going to be equal to minus 4. So real with real, imaginary with imaginary. So now I can make two equations. 4x minus 4 is equal to 8. 7y minus 6x is equal to minus 4. Let's the left number to the right. So 4x is going to be equal to 8 plus 4. 4x is going to be equal to 12. Divide both sides by 4. I'm going to get x is equal to 3. Gorge, I figured out what x is. Let's look at the second equation I made. So 7y minus 6x equals minus 4. Well, I can't really do anything with that at the moment until you realize, hey, I have x equals minus 3. So let's sub that in. 7y minus 6 times 3 is equal to minus 4. 7y minus 18 equals minus 4. 7y is going to equal to, so bring this over, going to become a positive. So my right hand side is going to be 14. And then divide both sides by 7. I'm going to get y is equal to 2. So there you go. I have solved an equation with x and y by using equalities there. So let's look at some exam questions. So determine the value of x and y to satisfy this equation. So this is very similar to the one we have above. So I need to kind of expand out and gather and group my real and imaginary parts on my left hand side, and then let them equal real with real, imaginary with imaginary. So I'm going to have 4x plus 3yi minus 2 minus 5x. So say I. So that's going to be minus 2i minus 5xi is equal to 10 minus 6yi. So I realize here all of these have an I component to them. So I'm going to factor out an I here. So I have 4x. 4x, factor out an I, I'm left with 3y minus 2 minus 5xi equals 10 minus 6yi. So, real with real, imaginary with imaginary. So, 4x is my real component. That's going to be equal to my real component on the right hand side. So, therefore, my first equation is 4x is equal to 10. Therefore, x is going to equal to 10 divided by 4, which is 2.5. Gorge. Let's look at my second equation. real with real, imaginary with imaginary. So 3y minus 2 minus 5x is going to be equal to minus 6y. So 3y minus 2 minus 5x equals minus 6y. So we see here I have things in x and y, but I know what x is from my first equation. X is equal to 2.5. So sub that in, I get 3y minus 2 minus 5 times 2.5 equals minus 6y. So letters to the left, numbers to the right. So I'm just going to gather all of my y's together. So I'm going to bring letters to the left, numbers to the right. So I'm left with 3y plus 6y is equal to, so minus 2 minus 12.5. 12.5, that's going to be minus 14.5. Then when I bring it over the equal sign, that's equal to positive 14.5. So I have 9y equals 14.5. Divide both sides by 9. I'm going to get here y is equal to whatever that means. Let's see. So 14.5 divided by 9 is equal to, I'm getting here like 1.61. Well, you probably leave it as a fraction, but I'm using my phone. Oopsies. Right. So let's look at this one here. If x plus yi plus y minus xi equals 8 plus 2i, use simultaneous equations to find the value of x and y. So we need to make two equations here. So real with real, imaginary with imaginary. So I know x plus y is going to be equal to 8. That's my first equation here. X plus y is equal to 8. Let's look at my second equation. Y minus x is going to be equal to 2. So minus x plus y is going to be equal to 2. Now I have a simultaneous equation here, so I need to cancel out x or y. I'm going to cancel out x here because they have the same coefficient but opposite signs. Add them up. X minus x is 0. Y plus y is 2y. 8 plus 2 is 10. Divide both sides by 2. Y is equal to 5. And then finally, I want to find what x is. So sub it into an original one. I'm just going to sub it to the first one here. X plus 5 is equal to 8. X is equal to 3. There we go. Bada boom, bada bing. Let's move on to the next one. Find the real numbers a and b if a plus bi times 3 minus 2i equals 5 plus I. So we can do this two ways. We can use division or we can just use our equalities. But shockingly enough, this is the equality section. So let's use our equalities here. So a times 3 is going. Actually, no, what, division will be easier here. But okay, you know what? We'll do it the other way. So one way you could do is you could divide both sides here by 3 minus 2i. Then you're left with a plus bi equals 5 plus I divided by 3 minus 2i. And then all you need to do is evaluate this division. Or what you could do is multiply this out and then equate real with real, imaginary with imaginary. So a times 3 is 3a. A times minus 2i is minus 2ai. Bi times 3 is plus 3bi. Bi times minus 2i is going to be minus 2bi squared. So 3a minus 2ai plus 3bi is going to be minus 2b times minus 1, which is plus 2b. And that is equal to 5 plus I. So remember, real with real, imaginary with imaginary. 3a, 2b is going to be equal to 5 because they have no i's on it. That's my first equation. My second equation is going to be minus 2a plus 3b is equal to 1 because the coefficient of this I here is 1. So minus 2a plus 3b is equal to 1. Now we solve these simultaneous equations. So I'm going to cancel out a here because they already have the minus signs already with them. So I need to make sure they're both the same number. So I need to find the lowest common multiple of 3 and 2. So multiply the top by 2, the bottom by 3, because the lowest common multiple of 2 and 3 is 6. So my top line is going to be equal to 6a plus 4b is equal to 10. The second one, minus 6a plus 9b is equal to 3. Add them up. A's go to 0. 13b is equal to 13. Divide both sides by 13. B is equal to 1. I solved what B was. Now you just sub it back into one of the original equations to find out what A is. So I'm going to sub it into equation 1 here. So 3a plus 2 times 1 equals 5. 3a plus 2 equals 5. 3a equals 3. A is going to equal to 1. You divide both sides by 3. One more example here. So, given z1 equals 4 minus 3i and z2 equals 5 plus 5i as two complex numbers, if z1 plus p times z2 equals k plus 0i, find the values of p and k, where p and k are real numbers. So this is a bit of a tricky one. So, 4 minus 3i plus p times z2, which is 5 plus 5i, is going to equal to k plus 0i. So 4 minus 3i, p times 5 is 5p. Then p times 5i is plus 5pi is equal to k plus 0. So real with real, imaginary with imaginary. So 4 plus 5 is going to be equal. So 4 plus 5p is equal to k. And then the second equation here is minus 3 plus 5p, so a different color here, minus 3 plus 5p is going to be equal to 0. Well, it has to be 0i. It goes 0. So minus 3 plus 5p equals 0. Therefore, 5p is equal to 3. P is going to equal to 3 over 5. Now I know what p is. I can definitely solve equation 1 now. So 4 plus 5 times 3 over 5 is equal to k. 4 plus, put this in your calculator or just cancel out the 5s. We're going to get 3 is equal to k. 7 is equal to k. And that is my other answer there. So we solve for p and k. Finally, let's look at two exam questions now. So this one came up in the 2017 Leaving Cert O level paper. So 2z minus 6 times 4 minus 6i equals minus 1 plus I 4 minus 2i. Oh, it's asking us to solve for z. So we don't even need to equate real with real, imaginary with imaginary. I already have z built in here. So I just need to get everything over to the right hand side and get z on its own. So I'm going to have 2z minus 6 times 4 is 24. Minus 6 times minus 6i is plus 36i. Is going to be equal to minus 1 times 4 is minus 4. Minus 1 times minus 2i is plus 2i. I times 4 is 4i. I times minus 2i is minus 2i squared. So 2z minus 24 plus 36i equals. So minus 4 minus negative 1, because remember I squared is negative 1. That's going to be plus 4. So they are actually going to go to 0, because it'll be minus 4 plus 4. So my right hand side is going to be 2i plus 4i, which is 6i. So 2z equals 6. So bring everything over to the right hand side. So plus 24. Then 6i minus 36i. So when we bring it over, we change the sign. So 6i minus 36i. 2z equals 24 minus 30i. Want to get z on its own. Divide both sides by 2. So z is going to be equal to 24 divided by 2 is 12. Minus 30i divided by 2 is minus 15i. How fun is that one? And then finally, let's look at the last one here. So this from the... Ooh, this is nice. This is from the Leaving Cert higher level paper, the 2021. So I have here 4 minus 2i all over 2 plus 4i is equal to 0 plus k. Right, k is a integer and I squared equals minus 1. Find the value of k. This is just algebraic division. No, this is complex division, right? 4 minus 2i all over 2 plus 4i. Complex division, top by top, bottom by bottom. So multiply the top by the conjugate of the bottom here. So it's 2 minus 4i. Sorry. 2 minus 4i. Then multiply the bottom by 2 minus 4i. So I'm going to have 4 minus 2i times 2 minus 4i all over 2 plus 4i times 2 minus 4i. Multiply it out. 4 times 2 is 8. 4 times minus 4i is minus 16i. Minus 2i times 2 is minus 4i. Minus 2i times minus 4i is plus 8i. All over 2 times 2 is 4. 2 times minus I is minus 8i. 4 times 2 is 8i. 4i times minus 4i minus 16i squared. So the top here, so that's 8i squared on top. So the top here is going to be 8 plus 8i squared. So remember, I squared goes to minus 1. So this whole thing becomes minus 8. So 8 times minus 8, well, that's 0. So they're going to cancel out, gorge. Then minus 16 minus 4i is minus 20i. All over the minus 8i plus 8i are going to cancel out. So I'm left with 4 minus 16 times minus 1. So that's going to become a plus 16, which is 20. And that is going to give me here minus I. And the complex number is 0 minus I. And if that equals 0 plus ki, real with real, imaginary with imaginary, that just means k is equal to minus 1. Right? I hope this video was some help to you guys. And I'll catch you guys later. Bye.